Today, we're attempting to cut through some of the noise around generative AI.
A lot of noise out there.
Exactly. And we want to bring you the truly essential components, the bits that power these incredible systems. So whether you're prepping for a big meeting maybe, or you're just really curious about how this stuff actually works.
How it all fits together.
Yeah, this deep dive is kind of your shortcut to being genuinely well-informed. We're going to dissect the generative AI tech stack. We're pulling insights from a really comprehensive guide that gives this great architectural view of how these systems get built.
And that's really our mission here, isn't it? To unpack this landscape, because it's evolving so fast. We want to go beyond just what everything is.
Right.
And really hit the why. Why does each component matter?
Yeah.
And crucially, how do all these pieces actually connect to drive the innovation we're seeing? It's about understanding the sophistication needed to build these robust GenAI apps. Everything from infrastructure right up to model safety.
Okay, let's get into it then. Let's unpack this, starting right at the bottom, the very foundation.
The bedrock.
The bedrock, exactly. We're talking cloud hosting and the infrastructure backbone.
That's right. And it's absolutely crucial. This foundational layer, it's what handles all the heavy lifting for any GenAI workload.
Heavy lifting, like?
Well, the intensive demands of model training, for starters, then efficiently serving those models through inference, which is essentially, using the trained model to make predictions or generate outputs.
Okay.
And making sure everything can scale dynamically, as demand just explodes sometimes. Key functions here are things like GPU and TPU acceleration, those specialized chips that make AI calculations super fast.
Right, the parallel processing.
Exactly. Plus, auto-scaling capabilities, optimizing costs, which is huge, and providing those real-time inference endpoints so apps get responses instantly.
So this isn't just raw power, it's also about elasticity, right? Like how a small startup could suddenly handle millions of users if their AI app goes viral.
Without rebuilding everything.
Yeah. That's amazing compared to old IT. So who are the big players here? Who's providing this foundational stuff?
Well, you've got the usual suspects, the hyperscalers, AWS with SageMaker and Bedrock, Azure has their OpenAI service, GCP offers Vertex AI.
Makes sense.
But what's really interesting too is the rise of more specialized providers. Think NVIDIA NIM, CoreWeave, Lambda Labs. They're focusing specifically on that high-performance GPU compute. It just shows how critical and specialized this infrastructure layer has become.
And are there newer trends making this even more efficient or accessible?
Oh yeah, definitely. We're seeing things like serverless inference emerging. That's a big deal because it means you only pay for the exact compute time your AI uses.
Scales from zero instantly.
Exactly, without managing any servers. Then there's edge AI deployment processing closer to the data source for less delay, lower latency. And also model as a service, MAS, which basically abstracts away all the infrastructure complexity, makes complex models easier to access.
Okay, so we have the power grid set up, essentially. Now we need the actual intelligence, right? The brains of the operation.
So that brings us to foundational models. These really are the core of GenAI systems. They offer these broad, general capabilities that you can then adapt for, a huge variety of tasks.
So not just chatbots.
Oh, way beyond that.
Yeah.
Think of them as this incredibly versatile raw material, like clay, that you can mold into almost any AI application. It's a huge shift from the old way of building bespoke models for every single little task.
Right.
When we talk large language models, LLMs, you're thinking names like GPT-4, Claude 3, Mistral, LLM, Gemini, DeepSeek, Yi, Mixtral, Command-R, plus Feed. The list keeps growing.
And the really exciting part for me is the rise of multimodal models, Gemini, GPT-4, Claude 3.5. These aren't just text anymore, are they?
Not at all. They handle and understand combinations, text, images, code, even audio sometimes.
So what does that actually unlock for us? How does that change how we might interact with AI?
Well, these models are behind your everyday chatbots, sure, but also coding copilots helping developers write code faster.
Huge time saver.
Absolutely. Advanced text generation for articles, creative writing, you name it. And that multimodal understanding lets the AI see and hear as well as read. That opens up totally new ways to interact.
Okay, powerful models are great, but for developers to actually use them effectively, there must be tools to simplify all that complexity. It can't be easy.
You got it. That brings us neatly to frameworks. They're designed specifically to simplify those, often very complex, interactions with the foundational models and all the other bits and pieces.
Making it more modular.
Exactly, more modular, more approachable. For instance, LangChain is really popular for chaining LLM calls together, building ARG workflows we'll get to RAG later, and even creating intelligent agents.
Okay.
Then there's LlamaIndex, which really specializes in helping LMs work with your own documents, like huge internal knowledge bases.
Ah, document aware.
Precisely. Hugging Face's Transformers library is kind of the go-to for training and fine-tuning models. And for the really core, deep model development, you're typically looking at PyTorch or TensorFlow.
Right, the classics.
Yeah. And then for quickly building user interfaces that are driven by LLMs, tools like Gradio and Streamlit are incredibly useful. Fast prototyping.
So these frameworks are like crucial translators almost, simplifying things, making GenAI development faster and easier for more people. It's about democratizing it in a way.
That's a great way to put it. Democratizing access.
Okay, speaking of making things easier, imagine trying to remember every single past conversation your AI ever had. Or finding one specific fact in like mountains of data. That sounds hard.
It is. And that's where databases and orchestration come into play. They're absolutely crucial.
For what? Exactly.
For managing memory, handling long context, and enabling really efficient information retrieval. Especially for retrieval augmented generation, or AGJ.
AGJ again. Okay. So these are like the AI's external brain.
Kind of, yeah. Or its nervous system, maybe. It lets the AI remember past interactions, pull specific facts from huge knowledge bases, and string together complex sequences of operations. It gives it a form of long-term memory and procedural intelligence.
Gotcha. And what kind of tools are we talking about here?
Well, for instance, vector databases. Names like Pinecone, Weaviate, ChromaDB, Qdrant, Milvus. They're specifically designed to store and search those numerical representations of data, the vectors that AI models use.
So they understand the data similarity.
Exactly, through math. And for orchestrating the complex workflows, you have tools like LangChain Expression Language, LCEL, or more general workflow tools like Airflow or Prefect. They manage the flow between different AI parts.
This really answers that question, doesn't it? How does an AI actually remember what you just talked about? Or find that one obscure fact in 1,000 documents?
These tools are the answer. They enable use cases like RAG, pulling in external info to make answers more accurate.
Right.
They enable semantic search, searching by meaning, not just keywords, so large canine finds big dogs.
Clever.
And yeah, giving agents that long-term memory, letting them recall info beyond their immediate context window.
Okay, but what if one of these big general models isn't quite right? Like, it's good, but not perfect for my specific industry or task.
No, well, that's when you need to get a bit more hands-on. That's where fine-tuning comes in.
Customizing the model.
Exactly. Fine-tuning is all about customizing those powerful base models to perfectly fit a niche domain or a very specific task. You're adapting that general knowledge to your unique needs.
So you're not building from scratch.
No, heavens no. That's the beauty. You leverage potentially billions of dollars worth of pre-training, and then you just precisely mold it for your specific nuanced task. Saves immense compute time and cost. It turns a generalist into a specialist.
What kind of tools help with that?
You've got things like the Hugging Face Trainer Library, weights and biases for tracking all your experiments. Very important. And techniques like LoRa and QLoRa adapters.
Yeah.
These let you efficiently tweak just a small part of a massive model rather than retraining the whole thing. Tools like Axolotl help implement this.
Parameter efficient, right?
Parameter efficient tuning, exactly. And there are also dedicated platforms simplifying this, like OctaML, MosaicML was one. AWS SageMaker Jumpstart has options too.
And the main techniques?
The big ones you hear about are supervised fine-tuning, or SFT. Then there's reinforcement learning with human feedback, RLHF, which is famously used to align models, and those parameter-efficient methods like LoRa and QLoRa we just mentioned.
It's really fascinating how much control that gives you without having to start all over again.
It's a game changer for specialization.
Okay, so before any model can even start learning, the raw data itself needs work, right? It needs to be prepped and understood in a way AI can actually process.
That's absolutely fundamental. That's where embeddings and labeling come into play.
Your embeddings, those are the vectors again.
Yep. These tools convert raw input text, images, whatever, into that numerical vector space. That transformation is what allows for super efficient search and similarity comparisons that the AI models rely on.
And who provides those?
Providers like OpenAI, Cohere, Hugging Face offer embedding models, GenAI as well.
Okay, and labeling.
Labeling goes hand in hand.
Yeah.
Tools like Scale AI, Labelbox, Snorkel, Datasaur. These are absolutely critical for preparing the high-quality training data.
Garbage in, garbage out, basically.
Precisely. Good labeling ensures your models learn correctly and perform accurately. They're kind of the unsung heroes of effective AI development.
So for you listening, these technologies, embeddings, and labeling, they power things like that semantic search we talked about. They make RAG work well. They allow for clustering similar data points and accurate classification. They turn concepts into math the AI gets.
Well put.
Now, here's a thought. What if you just don't have enough real-world data? Or maybe you have serious privacy concerns about using the data you do have.
Yes. There's a clever solution emerging for that. Synthetic data.
Faking it till you make it.
Sort of. Synthetic data tools create realistic but entirely artificial data. It looks and feels real statistically, but isn't tied to actual events or people.
And why would you do that?
Well, primarily to augment existing data sets. You can fill in gaps where real data is scarce or maybe too sensitive to use directly.
Okay. What tools do this?
You see names like Gretel AI, mostly AI, Tonic. There's even Cynthia, which is specifically for creating realistic but fake healthcare data.
Healthcare finance. I can see where privacy is huge.
Exactly. So the use cases are filling those data gaps, enabling privacy-preserving training because no real individuals are involved, and also helping to balance out data sets if you have way more examples of one class than another. Hugely valuable in regulated industries.
Makes sense. Okay, so we've built the model, maybe fine-tuned it, fed it good data. Now it's deployed out in the wild. You can't just walk away, right?
Absolutely not. You need to keep a very close eye on it. That's where model supervision and observability become critical.
What are we observing?
You're tracking the quality of the model's output in real time. You're looking for problems like hallucinations, making things up.
Right, that's a big one.
Huge. You're monitoring for performance drift. Does it get worse over time? And identifying biases that might creep in once it interacts with real-world data.
And the tools for this?
Key players include Fiddler AI, Helicone, Y-Labs, Arise AI, TreeSloop is another one.
What kind of metrics are they tracking? Is it just accuracy?
Oh, much more than that.
Yeah.
Latency and the throughput, is it fast enough? Toxicity, bias, those hallucination rates we mentioned, but also cost and token usage, which directly impact your operational budget.
Right, because every call costs something.
Exactly. This is really where the rubber meets the road for an AI that's actually deployed and being used. You have to watch it constantly.
It's clear it's not enough just to build them. You have to manage them actively. And tied very closely to watching them, I imagine, is making sure they're behaving responsibly, safely.
Yes, precisely.
Yeah.
That leads us to model safety, guardrails, and compliance. This is an increasingly vital part of the whole stack.
Why so vital now?
Because these models are so powerful, the potential for harm if they go off the rails or produce biased or unsafe content is significant. Plus, regulations are catching up, so these tools ensure models are safe, ethical, and compliant.
What kind of tools are we talking about?
Tools like LLM Guard, Guardrails AI, Arthur AI focuses on this too, Gerac for probing vulnerabilities, Rebuff against prompt injection.
Prompt injection, like tricking the AI.
Exactly, trying to make it bypass its safety rules. So these tools perform functions like input-output validation, catching problematic stuff going in or coming out. They enable red teaming and adversarial testing.
Red teaming, like cybersecurity.
Very similar. Dedicated teams actively try to break the AI, find its weaknesses, get it to produce harmful outputs before malicious actors do. They also provide that prompt injection protection and crucial filtering for sensitive data, like PII under GDPR.
So connecting this to the bigger picture, this is all about building trust, right? Proactively putting in safeguards so we can rely on these powerful tools.
Absolutely. It's about ensuring the AI we deploy aligns with our values and the law, not just works technically.
Wow, okay. That's a lot of layers already. And just when you think we've covered it all.
There's always more. There are even more layers expanding their whole GenAI ecosystem. A few bonus concepts, maybe?
Let's hear them. What else is part of this stack?
Okay, first, agent frameworks. These are really taking off. They help build more autonomous agents, AI systems that can do complex reasoning, make decisions, handle multi-step tasks on their own.
Like AI assistants that can actually do things.
Yeah, think tools like LangGraph, AutoGPT cause to stir, Crew AI, MetaGPT. They enable use cases like complex multi-step code writing or breaking down a big goal into smaller, manageable AI tasks. It's about orchestrating capabilities.
Interesting. What else?
Then there are evaluation and benchmarking tools. These are super important for objectively measuring how well an LLM actually behaves. How accurate is it? How truthful?
Comparing different models.
Exactly. Tools like the Eleuther AI evaluation harness, the OpenLM leaderboard online, RDEAs is specifically for evaluating RE systems. They help compare and improve models. They use metrics like BLEU and Rouge for text quality, Truthful QA for fact-checking, GPT Fuzz for robustness, and tracking that hallucination percentage. Vital for knowing what really works.
Okay, 2 more.
Yep. We absolutely have to mention the open source ecosystem and datasets. This is huge. The community provides a wealth of models: Mistral, Phi-3, Llama, Falcon, Orca. The list is long.
Models you can just download and use.
Or adapt, yes.
Yeah.
And massive datasets too: C4, Pile, RedPajama, SlimPajama, OpenOrca, the Dolly dataset. This open source movement fuels incredible innovation, lowers barriers to entry, and offers cost-effective options for everyone.
Can't underestimate open source. And finally,
governance and compliance. Tools and practices specifically designed to track AI usage, ensure responsible deployment, and adhere to all those evolving rules and standards.
like the EU AI Act.
Exactly. Think tools or features like Azure OpenAI governance capabilities, platforms like Credo AI, IBM Watson governance. It's all about accountability, responsible innovation, adhering to GDPR, IPA, whatever applies.
Okay. So when we take a step back and look at this entire stack, from the cloud foundation through models, frameworks, data, safety, all the way to agents and governance. Wow. What does this whole picture tell us?
It tells us it's complex.
Yes, definitely complex. What an incredible journey, though, diving deep into this generative AI tech stack. We really went from the foundational compute power
All the way up.
all the way through the core models, the frameworks making development easier, the databases giving AI memory, crucial fine-tuning, data prep, and those absolutely essential safety and governance layers.
Every single piece plays a critical, interconnected role.
Yeah, it really highlights how bringing these powerful AI applications to life isn't just about having a good model.
Not at all. Understanding these interconnected systems, even at a high level like this, really empowers you to grasp the innovation that's driving AI today. It's clear it's a sophisticated orchestration, a symphony of many, many parts working together. Gaining this knowledge, even quickly, puts you way ahead in understanding where this field is going.
Absolutely. So maybe a final thought for you, our listener, to chew on. Given this rapid evolution, this increasing complexity of the GenAI tech stack, how might the roles of the human experts and the AI systems themselves continue to evolve and maybe intertwine in the coming years, especially in tricky areas like, say, ethical oversight or even creative collaboration?
That's a great question to ponder.
It is. We definitely encourage you to keep exploring, keep asking questions, and keep diving deep into these fascinating topics.